We got our data from quantmod last week. So we can see here's the S&P prices. So I'm gonna load in 1,000 days worth of data. So the top 1,000 days, most recent 1,000 days worth of data into my price. So then what I'm going to do is put 900 days worth of data into price train, and then 100 days worth of data into price test. Note that I use tail to get the 900 days. So, I took the last 1,000 days, the most recent 1,000 days worth of data, and put that into my price. Then when I was looking at when I was creating price train, I took the oldest 900 days from my price. So I'm not using the entire price data here. This is the last 1,000 days worth. And then I'm putting the most recent 100 days into price test. Now I could have actually used GSPC here. It should be the same. So the idea is that I'm going to fit my model to price train, and then I'm going to predict what the model expects is going to happen in the last 100 days, and then compare that to what actually happened. So see how it goes. Next, I'm gonna put the numbers 1 to 900 in days, like in the variable days, because when I'm gonna fit my model, I'm gonna say these prices happened on these days, and then I'll attach another set of days to day's test. So what do I have to do? I'm gonna have to fit the model. So my model is gonna look at what happened with the stock market. So that's in price train during the period days, from 1 to 900. It's that easy. So what does that look like? Well, I just go plot price train. So price train is what the share or the share index was during the training period. Then if I just go AB line price model, it does the best fit line, fitting this data to this line. So that gives me my model. Next, I can look at what happens if I extend that line to the training time period. So, day 1 to 900, I use to, fit the model, and you can see the line does seem to get the broad trend. And now I'm going to look at what happens next. So I just go plot price test, and I can see that's what happened next. So I just go AB line price model to get what the prediction is. So if I just go back, I can see that if I fit the trend line for this period, these 900 days, it looks like the trend is down, there's a gradual downward move. At the same time, if I were to zoom in, from day 800 to 900, this period, that trend seems to be up. So on day 900, the price was what, about 1300? So when I go from day 900 to 1000, I see that it actually keeps going up. It dips a little bit, but it actually keeps going up. So the trend, the move, what actually happens ends up being an up move, while our model, which was fit on these days, this time period, was a downward move. So that introduces the whole issue of, well, predictions are not correct. You can't. It's not like, oh, I can use a fancy function from R, and now I'm able to predict the future. It doesn't work that way. This is a sensible, thought out strategy. So that's basically really all we can do. A variation that can be used, and is often used, is, well, if I'm going to predict 100 days into the future, I only look at the last 100 days. So I go, that's the time scale that's of interest. So if I had done that, I would have trained my data on this period from 800 to 900, and then my trend line would have been up and my forecast would have been up, which would have been closer for this specific test period. So there are some of the issues involved when making forecasts. So here we just used a linear model. We fit it to a period of data and made a forecast. So we haven't looked at all 4 data sets, and we haven't looked at the range of options that we have when fitting the model. So here I just used a linear model. R can do far more. So we'll look at that next before applying it to our 4 different data sets.